This next session now is on crop management, and it's in the context of present and future challenges, which we know there's a lot of. So Stephen is going to kick off on wheat disease control. Then we have Deirdre Doyle has the latest on Ramallaria and barley. Jack Jemison is going to talk to us about perceptions on establishment systems, and Stephen is going to come back up on the SUR. So Stephen, we'll let you go.
Okay. Thank you very much, Siobhan. So I'll jump straight into it. And I suppose to give a very quick background to the talk or the presentation that I'll be giving. Look, Septoria continues to be our most important or most damaging disease of winter wheat crops. Look, there's undoubtedly a number of different measures that we can take to control the disease, from varietal resistance, nutrition, to timing of sowing, etc. But fungicides still remain a sort of a key or critical component in the disease control management of it. I suppose when I stood up here last in 2020, we've had some major changes since then in terms of our fungicide regimes, in terms of fungicide availability. We lost chlorothalonil, which was a key sort of fungicide in the management of Septoria, but we've also gained we've gained two new molecules that have actually provided us with, I suppose, very, very good efficacy. And really, because fungicides and fungicide control programs still are such a critical part of the disease control strategy, we need to be aware in terms of how we manage that, in terms of resistance management and sensitivity. So just to put what we have or what changes we've seen in context, if we look at the graph on the right-hand side of the graph, we can look at the fungicide dose response, we can look at our SDHI in the form of Intrex, and we can look at our older azole in the form of proline or Prothio. What we can see is that in 2021, in a protective situation, they were given below 50% disease control. Put it in context, the replacement for chlorothalonil in Fulpit is given a bit between 50 and 60% control. So in those two molecules, we can see what resistance has impacted in terms of the efficacy. As we moved into the newer sort of actives that arrived in 2020 and became available in 2020, Revistar, which is your Revysol, the new azole that would have been brought to market, is a combination of it with Intrex. So you can clearly see what the azole Revysol has brought in terms of disease control. And Univoc, which is your Inatrec and Prothio co-formulation, you'll probably be more familiar in terms of the straight, which is either Questar or Peacock. You can see actually in the Univoc is a co-form with Prothio, so you can see exactly again what that new active in the Inatrec has brought to disease control. So they really have brought back levels of disease control as opposed to where we would have been with the SDHI azoles maybe some 10 years ago in terms of that level of efficacy. So it really is important that actually going forward, we manage these actives so that we don't have resistance development, or if we do that, we delay the spread of that and its impact on efficacy. In terms of the research side of it, a key component of doing this is actually setting baselines, so establishing what level of sensitivity is there before these molecules came to the market. And that's something that we have been doing over the last number of years, is trying to get this baseline data so that we can monitor changes if they do occur in the population, so that we will be able to give advice in terms of our fungicide control programs. To do this, we've worked with colleagues in Europe in terms of a EuroRes project, where we identified a crop in 5 different European countries. We sampled it and tested the sensitivity in the lab to both those molecules, the pure active in the Inatrec and also then the Revysol, the azole. Differences, of course, we will inevitably in a population, you will see some differences. And we tested actually the differences that would have existed or were in those populations in terms of glasshouse to see was there an impact on efficacy, and if there is, how we might actually manage that going forward. Just to quickly run through some of the data that we would have identified if we saw, I suppose to look at fenpicoxamide first, and I'll briefly describe the graph that you're seeing. So basically, every dot is an individual isolate, so we can see populations from Belgium, Denmark, Germany, Ireland, and Sweden, and we had a collection of isolates going back to 2005, which we call our baseline for azole sensitivity. And if we look at the graph, the lower the value here, the more sensitive the population. And I suppose from an Inatrac perspective, if we look at the overall population, including everything together, it is relatively narrow range of sensitivity. It's what we would expect for a new molecule, a new chemistry that hasn't been, or the population hasn't been exposed to it. However, even within that, we do see some differences between the collections, with the Irish being less sensitive than some of our European neighbours in terms of that. The positive thing is that even within these isolates, we haven't detected mutations that are contributing to resistance. From mutagenesis studies, we have a very good idea of what mutations will arise, and we haven't detected those. Similarly, taking some of those more sensitive and comparing them to the less sensitive strains into the glasshouse, we didn't see any difference in efficacy. So overall, a positive in terms of that. We've established a very good idea of where the population is before the molecules came on the market. Similarly then with Revysol, we did the exact same, using the same collection of isolates. I suppose the difference here is that Revysol is an azole. We've been using azoles in wheat for almost 4 decades at this stage. So the range in sensitivity that we detected is much greater, as you can see from the chart. So basically, it tells us that there's a wide range of sensitivity, a very wide range of sensitivity in the population. Again, when we look at the individual countries, I suppose the Irish population is less sensitive than some of the European neighbours. To be expected, I should say, as we know that azole sort of have azole resistance or decrease in sensitivity has been present in the Irish population for 10 years or more at this stage. And we can actually relate that to target site or CYP51 mutations, but also efflux activity, which is basically the chemical being actively pumped out of the cells. One thing that we would say, in addition to looking at Revysol, we also tested to a range of these populations, to a range of different azoles. And what we see is what we'd expect for some is a complete cross-resistance. It's what you would expect. They're targeting the same site. But for others, it isn't as complete. And I think the case would be that between, I suppose, Revysol or mifentrifluconazole and prothioconazole, it isn't as complete in terms of what it might be between some of the other azoles. Taking some of these less sensitive strains, or I suppose the strains that would be at the top of the chart here, which are less sensitive, and comparing them to the most sensitive strains, in glasshouse, we do see that there is a difference in terms of the efficacy. So those that are at the, I suppose, less sensitive are that little bit more difficult to control under glasshouse conditions. And this is important in terms of how we use these fungicides. So really, that brings me very quickly to, I suppose, some of the conclusions or recommendations that we would see from this. I suppose the key thing, and it's something I would have always sort of stood on the podium and sort of recommended, is that the fungicides are not used solely. They're used in mixtures with other modes of action that have activity against that pathogen. This is very important. I think we know that Inatreq and Revysol, look, they are at risk of resistance development. We know that mutations that potentially will arise towards Inatreq. We know that the population, there are strains that are a little bit more difficult to control for Revysol. So it is a case that we should be managing them accordingly, and that should be only using them once in the program, within the program. Of course, as previously would have been vital with chlorothalonil, we see the multi-site component in a winter wheat disease control program is essential, and we'd be talking about a multi-site. Look, that's predominantly fulpit in this sort of scenario now at this stage with the loss of chlorothalonil, and that should be at leaf 3 and leaf 1 timings. I suppose the final thing to say is that from a disease control perspective, we do need to be aware of other diseases. Although septoria is our major one, we do need to think about potentially other diseases that might come in, and one that springs to mind is yellow rust. We know that the winter wheat crop is dominated by the variety Graham. We know that it does get some disease or low levels of yellow rust potentially early in the season, that it tends to, I suppose, grow out of it or provide some adult plant resistance later on. But if there is some bad outbreaks, it could impact, even though we do have that adult plant resistance, it could impact some of those upper canopy to a certain extent. So to be aware of that. Finally then, look, I want to acknowledge, look, a lot of work goes into actually doing these baseline studies. Now, as Fiona Hutton would be the lab manager and would have overseen a lot of that work, but equally our partners throughout Europe that are providing us with samples and sort of collaborating to get this. We know that the pathogen itself isn't just going to be isolated in Ireland. It is a case, it spreads quite rapidly throughout Europe. So I think at that, Siobhan, I'll hand you back the floor.
Thanks, Stephen. And look, we'll take questions from Stephen at the end, get them in on Slido. And I should have said earlier on, there's a poll there on Slido for this session as well. So the poll is looking at how much of a yield decrease, similar to the question this morning, you'd take, depending on how leaving out fungicide and the resistance varieties. Just read the question carefully. I don't have it in my head now. Deirdre, work away there.
Thank you, Siobhan. Okay, so I am just going to give an update on ramularia control in winter and spring barley. Okay, so just to start then, what exactly is ramularia? So you can see in the picture there on the right-hand side of the slide, These are your typical lesions that you will see on a barley plant that's been infected with ramularia. So ramularia is a disease that attacks the crop late in the season, with stressed crops more likely to show symptoms. Once these symptoms develop on the upper leaves and in the upper canopy, particularly after flowering, treatment is generally not that effective. And the yield loss from ramularia relates directly to the loss of photosynthetic area. So when it comes to understanding why ramularia is important to yield, it's important to know how your barley yields are created and then how to protect them. So to start with, we need to create these yields. This means that the crop needs to produce a high number of tillers in order to have a high number of potential grain sites. And this is where your fungicide application comes in at growth stage 31 to 32, or the start of stem extension, to protect these tillers. So then we move on to protecting the upper canopy of the plant. So your fungicide application at growth stage 45 to 49, or when the awns are just starting to emerge, is very important here. This it's obviously important for all diseases, but in particular from a ramularia control point of view. It's designed to make sure that the plant has enough green leaf area for photosynthesis for grain fill. So now I'm just going to talk about some of the control challenges that we have for ramularia. So obviously, as Stephen mentioned there, we lost chlorothalonil in 2020. We know we have some fungicide resistance to a range of our different products, so across the SDHIs, the azoles, and the strobilurins, and the unreliability of varietal resistance for ramularia. So what I'm going to show you from here on are some of the results from trials that we've carried out on winter and spring barley over the last couple of years, looking at what fungicides that we still have that are working on ramularia. Is Folpit a replacement for chlorothalonil, and is there a variety effect? So to start with then, these are going to be results from some spring barley trials that we carried out over a number of years. Just say we also did this on winter barley, but just in the interest of time, I'm just focused on spring barley here. So this trial was looking at a range of different products, all applied at a full rate at awns emerging, to compare their level of disease ramularia control to chlorothalonil. So you can see here on the left-hand side, they are on the graph, that is the ramularia results, so the amount of ramularia in the plots. So in the blue is the fully untreated plots. They had an average of around 65% ramularia, so quite high levels of ramularia there in the trials. Then this in the brown then is chlorothalonil or Bravo. So you can see when that was applied, there was only around that reduced the amount of ramularia to around 20% on average. So showing very good levels of control. Now, with this group of fungicides, we have there's a strobilurin, an SDHI, and cyprodenil. You can see that with these fungicides here that they were struggling to control ramularia to the same level as chlorothalonil. And then on the right-hand side, we have Phoenix, which is Folpit, and Proline and Revistar. So again, you can see the Phoenix is doing a decent job of controlling ramularia, not to the same level of chlorothalonil, but still giving something. And with the Proline and the Revistar, again, giving quite good levels of control there. So then I'm just going to look at the yields from this particular trials. So again, on the left-hand side in the blue, these are your fully untreated yields, giving an average of around 7.5 tonnes per hectare. In the brown is when chlorothalonil was applied. So again, you can see from the amount of disease control, it was giving the big increase in yield, nearly 1.5 tonnes there. And again, similar to the previous slide, so with this group of fungicides, you can see that they're all giving definitely giving an increase in yield over the untreated. However, in general, struggling to give quite the same level as chlorothalonil. And then on the right-hand side, then, so again, you have your Folpit giving a nice increase in yield there, and then Proline and Revistar doing a very good job there of increasing your yield. So that was where we looked at fungicides being applied on their own. So now I'm going to look as more of a kind of a program approach, really. So to see, is Folpit a replacement for chlorothalonil? So this is work that we did on winter barley on the variety Pixel. Okay, so to start with then, on the bottom in the blue is the fully untreated yields from this trial, giving an average of 8.6 tonnes per hectare. And above that, in the darker blue, this is where we applied a standard fungicide program, but with no multi-site included. So it was a Proline and Modem at the start of stem extension, followed by Siltra at awns emerging. And you can see, obviously, the big increase of yield there, up to 9.4 tonnes per hectare. So then above this again is where we applied the same fungicide program, but we added in chlorothalonil on submerging. So you can see so the addition of the chlorothalonil there, so the extra disease control, ramularia control, giving quite a big increase in yield, up to 10.2 tonnes on average. So then above this, these are results from where the yield results from where we applied Folpit within that program at a range of different timings. So obviously there is variability within the results there, but on average, including Folpit in your program, brought yields up to an average of 10 tonne per hectare. So doing a very similar job there to chlorothalonil. So just say, like, obviously including your multi-site there, definitely increasing your control of ramularia and then increasing your yield. Okay, so this leads me on to looking at the impact of variety for your yield. So this is some spring barley work again. We looked at the two varieties, Laureate and Planet. Laureate is in the dark green and Planet is in the light green. So again, here we were comparing the use of Folpit versus chlorothalonil in a program to see was one giving any better of a yield response due to disease control, and we can see that there was no significant difference in yield by including either of the two products in the fungicide program, which is obviously very positive because Folpit is our main option now that we have lost chlorothalonil. And then finally, just kind of an overview really as to how we will try to control ramularia in coming crops. So ramularia, it's a highly unpredictable disease, and unfortunately we can't rely on varietal resistance at the present for the control of it. We do know that ramularia is much more likely to appear in crops that are stressed. So the climate is a stress on itself. We can't do anything about that. However, what we can work on are our tank mixes. So just to, I suppose, try to, keep your tank mixes to a minimum. Try to keep the amount of actives in the tank at one time as low as you can. I mean, I know this is difficult at times, but it's just the more actives in the tank, the hotter the mix, and the more stress you're automatically putting on the plant. Then with nutrition, to provide adequate nutrition to the crop, making sure it gets the right amount of nitrogen and micronutrients that it might need. And then finally, to build your fungicide program to protect the crop as best you can. So as I was saying at the start, very important to protect your tillers. This is essential for the development of yield. And then to protect your upper canopy from all diseases, but in particularly from a ramularia perspective, and to include Folpit at this timing for your ramularia control. And just to say that when it comes to applying your fungicides, your timing is so important, particularly at that last application, to make sure it's going on when your awns are starting to emerge at the paint burst stage, not to wait until the ear is fully out, because at that stage, the fungicides just can't do the job that they need to do to protect the plant from disease. I'd just like to thank everyone that helped me with these trials over the last number of years. Thank you.
Well done, Deirdre. Thanks very much. And put your questions into Slido for Deirdre and indeed Jack. So Jack has been looking at growers' perceptions of crop establishment systems. So what did you find, Jack?
Okay, thanks, Siobhan. So today I'll be going over some of the results from a study of growers' perceptions about crop establishment systems. So for this study, we spoke to 154 tillage farmers who had more than 50 hectares of crops. There was a mix of plough, min-till, strip-till and direct drill growers in this study, and we captured their demographics. We also wanted to see where they were getting their information from and how they access this information. So as well as that, we really wanted to see how growers thought min-till and direct drill systems would perform in comparison to plough-based systems in terms of crop yields, pests, pesticides, grass weeds and soil quality. So first we look at growers' cropping area size. Just for the rest of this presentation as well, just to note, the views or responses of direct drill growers will be denoted by the blue bars, the views or responses of min-till growers by the green bars, and the views of plough-based growers by the red bars. So min-till growers had the largest average cropping area overall. Now this may have been a function of the higher work rates achievable with this system. Also interestingly, the growers who participated in this survey managed around 29,000 hectares between them, which is about 10% of Ireland's tillage area. So here we're looking at growers' occupations. So less direct drill growers had farming as their sole occupation overall. Now, this reality may have allowed direct drill growers to take more risk in adopting their system initially, as they were less reliant on farming. Also, the reduced labour requirement of direct drilling may have been a factor in system choice for these growers. And now we'll have a quick look at where growers were getting their information from. So here we're looking at growers' top-ranked information sources for major change decisions. So these major change decisions would be for something like maybe changing their crop establishment system, so for something substantial. I suppose the top information sources were Teagasc advice, other farmers, co-ops and merchants, and farm magazines and newspapers. But the key thing to note, though, is that the use of these information sources did differ with the crop establishment system growers were using. So if we take Teagasc advice here, for example, and Irish research, it's clear that a much higher proportion of plough-based growers are utilising these information sources than non-plough growers. Similarly, if we look here at international research, UK research and Base Ireland, a much higher proportion of non-plough growers seem to be utilising these information sources than plough-based growers. Okay, so interestingly, we asked plough-based growers how satisfied they were with their system. So over 40% of plough-based growers said they were unlikely to change away from the plough in the near future. A further, over 20% of growers said they were feeling pressurised to consider the adoption of a non-plough system, and approximately 35% of growers said they were currently actually considering the adoption of a non-plough system. So for the next 4 slides, I'm just going to give a quick overview of some of the things farmers thought for a range of different topics. So taking winter cereal yields first, we asked growers, did they think min-tilling would lead to changes in winter cereal yields compared to ploughing? So again, these bars denote what growers thought. So I suppose over 50% of both plough, min-till and direct drill growers thought that min-tilling would lead to no change in their winter cereal yields compared to ploughing. Of the remaining min-till growers, they were optimistic and favoured their own system. So they thought that min-tilling may lead to an increase in winter cereal yields compared to ploughing, and of the remaining plough and direct drill growers, they thought that min-tilling would lead to a decrease in their winter cereal yields compared to ploughing. And just to compare, we asked growers, did they think direct drilling would lead to changes in their winter cereal yields compared to ploughing? So I suppose the picture here is slightly different. A higher proportion of growers overall thought that direct drilling may lead to a decrease in winter cereal yields compared to ploughing, but a significant amount of growers, especially direct drill growers, still thought that direct drilling would lead to no change in winter cereal yields compared to ploughing. Okay, so when it came to herbicide use, we asked growers, did they think min-tilling would lead to changes in herbicide use compared to ploughing? So what's clear here is that the majority of growers, irrespective of system, thought that min-tilling would lead to an increase in herbicide use overall. And to compare, we asked growers, did they think direct drilling would lead to a change in herbicide use compared to ploughing? So again, the majority of growers did think that direct drilling would lead to an increase in herbicide use. But a small, but I suppose not insignificant amount of both direct drill and min-till growers thought that direct drilling may actually lead to a decrease in herbicide use overall. So we asked growers then what they thought the impact of glyphosate loss might be on each of the systems. So we'll take ploughing first. So we asked growers to give us a score between 0 and 10 on what they thought the impact of glyphosate loss might be. So a score of 0 would mean that glyphosate loss has no impact on the system. A score of 5 would mean the system can function, but it would need significant modifications. And a score of 10 would mean the system can't function without glyphosate. So I suppose a significant proportion of growers here thought that ploughing would be significantly impacted and significant modifications would be needed in order to function without glyphosate. So to compare, we asked growers, did they think both min-tilling and direct drilling would, how that would impact without glyphosate? So I suppose there's a stark difference in growers' perceptions here. The majority of growers thought that both min-tilling and direct drilling would be severely impacted, and that the impact of glyphosate loss on both of these systems would be detrimental, with a high proportion of growers thinking that both min-tilling and direct drilling systems would not be able to function without glyphosate. So finally, in terms of these systems' impact on soil organic matter levels, we asked growers, did they think ploughing would lead to changes in soil organic matter levels after 5 years of practicing the system? So I suppose the majority of growers here thought that ploughing would either lead to no change or a small decrease in soil organic matter levels after 5 years. And to compare again, we asked growers, did they think min-tilling or direct drilling would lead to changes in soil organic matter levels after 5 years. So I suppose taking mint tilling first, the majority of growers thought that mint tilling would either lead to no change or a small increase in soil organic matter levels after 5 years of practicing the system. And then when it came to direct drilling, I suppose a higher proportion of growers overall thought that direct drilling would lead to increase in soil organic matter levels overall. So to conclude, I suppose direct drillers had more off-farm employment, mint tillers had larger cropping areas overall, and in terms of information sources, Teagasc advice and other farmers ranked highly, and for non-plough growers, they relied more on non-Irish research and base Ireland for their information. And when it came to growers' perceptions, growers thought adopting different crop establishment systems will impact on yields, pests and soils. And I suppose the key thing is perceptions did differ both among and between groups. So going forward, what are our next actions? I suppose we need to check whether growers' perceptions are supported by research from conditions like ours. So this will be done in the form of a literature review, and I suppose where research doesn't exist to compare to growers' perceptions. So we want to see our growers bang on the money with their perceptions. Are they a little bit optimistic or pessimistic on some fronts? So where this literature doesn't exist, they'll be called information deficits, and we'll need to address them to give growers more certainty going forward. So I'd like to thank the growers who participated in this survey. I can see a lot of them out here, and I'd like to thank the team. Okay.
Thanks very much, Jack. Well done. They're big figures on the organic matter. I suppose it's part of a bigger system as well, the mint till and direct drill. Stephen is going to talk to us about the SUR, and Stephen, people still have time to get their submissions into the consultation, SUR consultation at agriculture.gov.ie. So that's an important thing to say.
Yep. Thanks, Siobhan. I was actually going to say the exact same. This does impact you all, so you should actually have a view in it and give your view on it. It is very important. I suppose following on from Jack's actually presentation, one of the interesting slides there is the perception of the loss of glyphosate. And I know I'm not dealing specifically with that, but within the SUR, I suppose it is some major aspects or some key pillars of that are to reduce the use of pesticides and the use of, I suppose, chemicals that are hazardous or regarded as hazardous. That's one of the key sort of aspects within it. Other things there are going to be to increase the use and enforcement of IPM, and also then to increase the use of non-hazardous or non-chemical alternatives to control pests. And with this in mind, I suppose the Department of Agriculture put out a call late last year to actually try and assess or to provide some overview on potential impacts that this may have, how we could address it, how we could provide information on it. And that's where we have been putting together a project called IPM, which is built up of 3 individual pod projects that I'll briefly go through just to give you an idea that this is some work that we will be doing, and hopefully in the next 2 years we will be able to present the data to you, but also provide the Department of Agriculture with information that is needed to sort of provide sort of feed through in terms of the proposed regulation. Just to go with the very first one of the things that we need to look at is alternative plant protection. We need to identify, I suppose, alternative means of controlling some of the pests. The first thing that we need to do is actually identify what are the key actives, the most important or the most widely used actives that are out there. These are going to be actives that we're going to have to target in terms of reducing. And from that, then, we will be looking at, okay, what alternatives exist and what efficacy could we expect from those alternatives? That data may not be available. We'll have to rely on expert opinion and feedback from stakeholders, etc. But we also need to look at actually, if there is impacts, maybe it is positive, maybe it will be negative, but what might be the economical implications of that? So there will be an economic assessment within this stage 1 alternative to plant protection. As I say, one of the other aspects within the regulation is the increase and I suppose provide sort of legal binding sort of use of IPM. To do that within the regulation, it's identified to provide crop-specific guidelines that have to be followed or should be followed in terms of pest management. So to do this, we need to actually identify what are the main pests that we're actually looking at. Now, pesticides are used across a large range of crops. To do this, we're going to start with specifically the arable crops. And we have, I suppose, more data available to us to actually tease out what pesticides are used, what are the key pests and what their impacts may be. But also then we need to look, similarly as before, what are the non-chemical alternatives that might be there? how effective are these? Basically, are they really good, or do we have data for that to say that actually these are providing that level of control? Or is it a case, again, that we have to rely on sort of outside data and then form our own expert opinion on that? So it'll be a qualitative and quantitative sort of assessment. And ideally, this will provide us through into providing those crop-specific guidelines. Stage 3 then is an overall impact assessment of the SUR. This is very much a desk-based literature review. What are the changes that the SUR is basically requiring us to do? What will the economic impacts of that be? But what will the environmental impacts also potentially be? If we have to replace some of these pesticides with non-chemical alternatives, will it have a positive impact on the environment or potentially could have a negative impact? We have to assess that. And hopefully, at the end of it all, then we will be able to provide a very much an overall implications of these changes. As I say, this is a project that will be starting in the next few weeks, and I hope to be able to stand here maybe next year to give an update, and then 2 years' time to provide these conclusions. So I'll pass you back to Siobhan as a very quick overview.
Thanks, Stephen. Thanks very much, Stephen. And Dermot Forrestal is going to join us now for the panel discussion, so you can keep sending your questions in. So the result of the poll, so the question was, if a more resistant wheat variety allowed one less fungicide to be used, how much yield reduction would you accept? So look, what do you think of those results, guys? 5% or 50% say 5% of yield reduction, 30% say 2%, and then obviously the bigger yield losses are not acceptable from growers. Stephen?
I think actually that when I see a 5% there, I take that as a very positive result, because we do know when we look at the recommended list that's coming through, 5% on the list will get a variety straight away onto it. But it might exclude some of those other varieties that probably would fit into that capacity to reduce our fungicide usage. Yeah. So I think seeing that is a positive sort of result, and hopefully will sort of give us confidence that some of those varieties that do come through with a lower yield are actually fitted or do suit our crops.
Dermot, do you think people will cut that one less fungicide?
People which?
Will they cut that fungicide? Like, it's a hard thing to do. It's a hard thing to get people to do. That's a big leap to take, you know, and if the yield reduction is more than 5%, you know, which is a possibility.
Yeah, that's why they put me here. I'm going to contradict Steve. No, I'm not at all. No, just in terms of general use. No, I think growers out there will look towards other alternatives. So if there is a decision support system, as we heard earlier, or if there is a resistant wheat variety that they think will be able to reduce their fungicide use, I think it will. And I think Stephen would tell you that, you know, even going back to years, there were decision support systems that, you know, would support less use of fungicide based on leaf wetness and things like that. So there's scope there. So it's good that growers are looking towards whether it's varietal or not. You know. Definitely
is. Okay, so there's a few questions up on the screen. Jack, I'm just going to, I'll read through these questions in a minute. I just wanted, something that caught my eye on the slide was growers feeling pressurised to move to minimum establishment systems or direct drill. Did they say where the pressure was coming from? Was it peers? Was it media? Or what was causing growers to feel that way?
I think it was a little bit everything. Like, as you've seen there, farmers placed a lot of heed in what other growers were thinking, and there's a lot of peer-to-peer learning going on, so I think that's certainly a factor. And yeah, I suppose it is covered a good bit in the media in terms of what Europe are pushing down the road that way, you know, so I think it is a little bit of both. Yeah. Dermot, do you have any comment on that, do you think?
Yeah, I think so. I think if you see a lot of coverage of something and a lot of that, and again, I think growers are, I suppose, looking to see something that will improve their sustainability. So growers are aware that there are issues out there. I think the challenge for us, though, is to know, well, are these the right systems and the right versions of systems to be moving to for our climate and our soils? Yeah. You know, that's really what we need to do. So I think, again, growers are wanting to have something that they see as being sustainable long-term into the future.
Yeah, important though that people don't feel pressurised. You know, every farm is different, and a plough might suit one farm and mint suits another. So important that people don't feel pressurised in the wrong way. Okay, moving to Slido. Stephen, sulphur often comes up. So is it an alternative to a multi-site? What do you think on that one?
Yeah, it is, being honest. I think it would have presented data on it a couple of years ago that would have demonstrated that, yes, it does provide disease control, and it is an alternative as a multi-site.
Yeah. And Stephen or Deirdre, on this one, there's a question here on biostimulants in reducing stress levels in Ramillaria. And Deirdre, I know you mentioned nutrition as well. I suppose nutrition would come into that too, so biostimulants and nutrition. to lower levels of ram malaria? Do you think there's a place for it?
Yeah, no, there's definitely a place for it. I suppose I didn't have anything to present there on it today, and we have started doing, we're on the very early stages of doing a little bit of work on it, so I can't really comment on it much, but definitely if there were biostimulants out there that would give consistent levels of control to try help reduce the levels of ram malaria, that would be great.
Yeah. The questions are moving here now, I just can't see them. Stephen, how important is it to keep high fungicide rates of Inatreq or Revysol, not just for disease control, but to slow resistance? And you had mentioned that in your panel.
High rates don't slow resistance. It's the opposite. Low rates slow resistance. The more we apply them, the faster resistance will develop and spread.
Yeah. There was a question there on cover crops. Oh yeah, it's back up. So can the use of cover crops increase disease pressure in the following crop? So I suppose earlier on we heard Louise and Sasha talking about the green bridge. I suppose it's more, well, we know in oilseed rape, that's one that's coming up more popularly now with clubroot.
In terms of, so the cover crops from a clubroot perspective it is an issue in terms of being able to manage it. If you are in an oilseed rape sort of in your system, then a careful selection of what cover crops are going in, it is very important. From other diseases, it's a little bit more difficult to actually tease that out. A lot of them might potentially be soil-borne, might be in the crops such as the clubroot, but also airborne diseases, like we know from a septoria perspective, like rotation, for example, won't control the disease. So it has a limited impact, in that aspect.
Jack, do you know the percentage of farmers that were using cover crops in your trial, or I suppose where min-till and direct drill were cover crops more common? You don't have to give figures, but...
Yeah, I think so. Yeah, certainly more common. They're switched to direct drilling or min-tilling for some growers. It's not just about changing the drill. There's a whole lot of different things that come with that, be it adopting a more diverse rotation or the use of cover crops, but it's using them at the right opportunity. I think growers will tell you that's the key thing,
Yeah, okay. Jack, there's another one for you there. Jack gathered information. To Stephen and the Revysol one, we'll just clarify that. You had it in your presentation, but only one, so or is it Inatreq or Revysol used once, or is it both can be used in the program, but only one spray of each? Yeah,
it's the latter. Each can be used in the program, but limited to one of each.
Yeah, okay.
The wording can be a little bit difficult in that.
Okay, these questions are moving here all the time. Deirdre, there was one that came up earlier from a member of the audience. Ram malaria is difficult to identify in the field. There's so many diseases on barley and everything. How can people actually identify it? And is it from the sun? Is it a spotting from the sun, or what is it?
Well, to be honest, it can sometimes be a little bit difficult. But I suppose there is a particular way of describing it or identifying it in the plant. So when the lesions, obviously they're not on the screen there now, but so there's 4 R's to remember. So it's like they're reddish brown in color. They're rectangular in shape with like a yellow halo around them. They go right through the leaf. So basically, if you turn the leaf over, the lesion should look pretty much exactly the same on the opposite side, and that they run with the leaf veins. So that's normally what they look like. So that's normally how to identify it on the plant.
There's a question there addressed to Jack. Dermot, I might put it to you though. Jack did identify knowledge gaps in some of the perceptions there from growers. So is there more work coming from Teagasc on this?
Yeah, I think this is part of the reason for Jack's work.
Yeah.
Because, farmers would rightly kind of criticize, I suppose, or question our work in terms of where we're limited to, I suppose, replicated trials like we have in Knockbeg, and there's a basic site that's there for a good number of years, which is hugely useful to us. We realise that, when you're talking about establishment systems, you're talking about a lot more than just the tillage system itself. Yeah. So there are a range of things out there to look at, and we were using some of Jack's PhD work, to try and identify where those knowledge gaps are so that we can fill them, because there's a huge amount of potential work in this area, so we need to be quite selective in what we need to pick to do. Yeah. So the next part of Jack's work is indeed to look at some of the perception questions, some of the sort of questions, and there's a whole pile more than Jack showed today, and to see, is there evidence out there that gives us confidence about those systems in our climate or not? And if there isn't, well, then we need to fill those particular gaps.
Yeah, okay. Yeah, and I think that's key, and there's a question there, was the perceptions correct? They're perceptions of farmers. So, you know, they are correct. They're the views of the farmers that think them. And as you said, Dermot, it's very important that those views inform where the research goes. A comment in there from someone saying to submit to the SUR, and I think all the panel will agree with that. So these questions are moving again, Shay. Where are we now? So how likely is it that Folpec could be lost from the market, and are there other multi-sites available? And I suppose, Stephen, to extend that, you know, is there other fungicides coming on? We have Initrek, Revysol. How fast are things coming? Are they quick enough to keep up with the resistance that's building?
So are there other multi-sites? I think the answer in terms of sulphur is one that, look, we mentioned at the start, so it is available. Whether Folpec will be lost, I don't have the answer to that. It's up for review, I think, in a number of years' time. In relation to new actives coming onto the market, look, we do know that there are products or molecules in the pipeline. We've been testing them a number of years. When we get them, if we get them, can't answer that question. I know it won't be this year, probably won't be next year. So there are new molecules there. We have to get them. So it gets back to, I suppose, the presentation that I would have given. What we have to protect. And it's means of measures that we need to be protecting those.
Okay, thanks, Stephen. And look, I was told to finish at 3 minutes, and we're at that now. So there is a few questions left. The speakers are around, and I'm sure very willing to take more questions later on. So thanks to everyone for your presentations.